and welcome to lecture 11. So, in the last class we defined the concept of price elasticity of demand, and if you notice, the price elasticity of demand, the way we defined it was the percentage change in quantity demanded resulting from a percentage change in price. There were two ways in which we had defined it. The first one was we had defined it as we had defined the price elasticity of demand as percentage change in quantity demanded as Q2 minus Q1 divided by Q1 times 100, and the percentage change in price as P2 minus P1 divided by P1 times 100. Okay. And then we took an example where we had the prices P1, we were given a demand curve, we were given a price P1 equal to 10, a price P2 equal to 15, we found out the corresponding quantities Q1 and Q2, we simply used the percentage change in quantity as Q2 minus Q1 divided by Q1 times 100. We computed the percentage change in price as P2 minus P1 divided by P1 times 100, and the percentage change in quantity divided by the percentage change in price gave us the price elasticity of demand. It turned out to be equal to minus 0.25, and recall, we know that because the demand curve is downward sloping, the price elasticity of demand is always a negative number. Then we said, what if we were asked to find out the value of price elasticity of demand at a particular point. So this is where we got into the point price elasticity, which was example 2, wherein we were given a demand curve Q equals to 20 minus 8P, and we used the price elasticity E as dQ dP times P by Q, because you can write the percentage change in quantity divided by the percentage change in price as dQ dP times P by Q. And we worked out this example. It turned out that the value of E again was minus 4. Then we defined three important notions of elasticity. One is what is called as when is demand elastic, when a 1% change in price leads to a greater than 1% change in quantity demanded, we say demand is elastic. Demand is inelastic if the absolute value of E is less than 1. A 1% change in price leads to a smaller than 1% change in the quantity demanded. Similarly, when a 1% change in price exactly equals a 1% change in quantity demanded, we say demand is unit elastic, right? And why were we concerned about whether demand is elastic, inelastic or unit elastic? Because the key takeaway was that if you are operating on the elastic portion of the demand curve and your objective is to increase total revenue, right? Your objective is to increase total revenue, the firm needs to reduce the price or give a discount. Alternatively, if you are operating on the inelastic portion of the demand curve, the firm will raise its price, and your revenue is maximized when demand is unit elastic. In fact, we went through the derivation and we learned that for a firm to maximize revenue, if I want to maximize revenue, I would set dTR dQ equal to 0. A little bit of algebraic manipulation gives us P times 1 minus 1 over absolute value of E is equal to 0, which gave us the absolute value of E is equal to 1. Now, let me take another example and tell you the power of using price elasticity of demand and how it can inform a firm what it needs to do, whether it needs to increase the price or whether it needs to decrease the price. So, let me call this as example 3. So, let us continue with the third example, where suppose we have a movie theater. So, suppose we have a movie theater which is selling tickets to two groups of consumers. Right. So, one of the groups we are going to call it as the general public. Let us call this given by the notation GP, and the other group we are going to call as the student group. We are going to denote it by S, right? And let us say that there are two specific demand curves for each of these groups. Now, the general public demand curve is QGP equals 500 minus 5 times P, and the student group is QS equals 200 minus 4 times P, right. So, we have the general public group as well as the student group, and the demand curves for these two groups are given by these two equations. Let us also suppose that currently the movie theater is practicing what is called as uniform pricing, right. So, I leave some space to draw the demand curves here. Right, and here the price is going to be in rupees per ticket, right. So, 500 minus 5p, so when p is 0, quantity demanded is 500, the number of tickets that is demanded is 500, and when p is 100, quantity demanded is 0. So, this is the demand curve for the general public. For the student group, when p is 0, the quantity demanded is 200, and when p is 50, the quantity demanded is 0. So, we have the two demand curves for the two groups, and suppose for a moment that the movie theater is practicing what is called as uniform pricing, which means that it is charging the same price whether it sells a ticket to the general public or whether it sells a ticket to the student group. So, suppose that the movie theater is practicing what is called as uniform pricing. And let us say the uniform price is p equals rupees 35 per ticket, right. So, irrespective of whether the individual belongs to the general public group or whether the individual belongs to the student group, the movie theater is going to charge the same price of p equal to 35 rupees per ticket. Okay. So, the question that we are interested in answering is the theater, I am just going to call it as firm, is the movie theater maximizing total revenue, right. Now, notice we have learned something about how can we use price elasticity of demand to answer this issue of what its total revenue is going to be and whether the total revenue is at its highest point or not. Okay. So, let us for a moment compute the price elasticity of demand for each of these two groups. So, a price of, so this is 50, so a price of 35, let me put it here. So, what I want to know is at a price of 35 rupees per unit, how many tickets are purchased by this group, and at a price of 35 rupees per ticket, how many tickets are purchased by this group. Okay. Using the demand functions, I can find out that the number of tickets purchased when the price is 35 rupees per unit or per ticket is essentially 500 minus 5 times 35. So, if you do the math, it turns out to be equal to, it turns out to be 325. So, 325 tickets are sold to this group. Similarly, for the student group, the number of tickets sold when the price is 35 rupees per ticket is 200 minus 4 times 35, which is 200 minus 140, which is equal to 60, So, let us find out what the price elasticity of demand is at each of these 2 points. Let us compute. Now, notice EGP. So, because I am interested in point price elasticity, I already know the demand curve. I also know at which point we want to compute the price elasticity of demand. I can essentially use this rule, E equals dq dp times p by q. Now, if I do that, notice for dq dp, right, the dq dp here is essentially dq gp dp, right. I am suppressing the subscript gp here. So, that is going to be the derivative of 500 minus 5 times p. The 500 will not contribute. I can pull the minus 5 out. So, I am just going to get minus 5 times the derivative of p with respect to p, which is going to be 1. So, minus 5 times 1 is minus 5. So, this is going to be minus 5 times the price at which I am computing divided by the number of units or number of tickets that the firm is selling to this group. So, minus 5 times 35 divided by 325. This arithmetic gives a value, you can check this, this gives a value minus 0.535385. Okay. So, this is the value that I get. So, currently as far as the general public group is concerned, at a price of 35 rupees per unit, 0.5385, right. This is a number in absolute terms less than 1. So, the firm or the movie theatre is operating on the inelastic portion of the demand curve. So, I am currently operating on the inelastic portion of the demand curve, right. And in particular, it is not at the unit elastic point. Why did we care about the unit elastic point? Recall that the firm is maximizing its total revenue with respect to this group, right, when it is operating at the unit elastic point. And currently we know that it is on the inelastic portion of the demand curve. Let us compute the price elasticity for the student group. So, that is again going to be dQs dP times P by Q. Now, notice the demand curve here is 200 minus 4 times P. So, dQs dP is going to be the derivative of this entire expression, 200 minus 4 times P. 200 is a constant, so that will not contribute. So, I am going to get minus 4 times the derivative of P with respect to P, which is going to give me 1. So, this is going to be minus 4 times the price, which is 35, divided by the quantity demanded, which is equal to 60. Now, if you do this arithmetic, it will turn out to be a value minus 2.33, right. So, I will write EGP here and ES equals minus 2.33. So, in absolute terms, this is a number which is bigger than 1. So, as far as the movie theatre is concerned and looks at the student group, it is operating on the elastic portion of the demand curve. Elastic portion of the demand curve. So, at its current uniform pricing scheme of 35 rupees per ticket, with respect to the general public, the movie theatre is operating on the inelastic portion. With respect to the student group, it is operating on the elastic portion of the demand curve. Now, we know both these cases are not in line with our notion of revenue maximization, because revenue is maximized at the unit elastic point. So, currently, the takeaway is that at the current uniform pricing scheme, the movie theatre is not maximizing its total revenue. And the reason being that the absolute value of E is not equal to 1 for both the groups. Right. So, currently I am earning some revenue. Let us compute what a revenue the firm is earning. The current revenues are, so current total revenue. So, I am charging 35 rupees per ticket times the total number of tickets that I am selling. Well, note this, I am selling 325 tickets to the first group, general public, and I am selling 60 tickets to the second group. So, that is 35 times 385. If you do this arithmetic, it will turn out to be a value rupees 13,475. This is my current total revenue. So, the question is, can the movie theatre earn more than this total revenue? Okay. So, that is going to be our next question that we are going to answer. Okay. So, let us write down the question as, what should the movie theatre do? What should the firm do in order to maximize its total revenue, right? So, what we have figured out is that at the price of 35 rupees per ticket, the firm is not maximizing total revenue. Now, let us think about this intuitively. Here, the absolute value is less than 1, and for the student group, the absolute value is bigger than 1. Now, think about the student group, right? The price elasticity of demand is a number bigger than 1. between the two groups, it is typically the student group which is going to be more sensitive to a change in price. Now, because the price elasticity of demand for the student group is a number bigger than 1, if you were to lower the price, right, if I were to lower the price, then the Q will increase by a lot more. How do I know that? Because the price elasticity of demand is bigger than 1, which will translate to an increase in total revenue. So, as far as the student group is concerned, what the theatre needs to do is to lower the price. In fact, bring it from a number 35 to some other number which is smaller than 35. Now, look at the general public group. Here the price elasticity of demand is a number less than 1. So, it is relatively inelastic, right. So, this group is not very sensitive to a change in price. So, if I increase the price, if you are on the inelastic portion of the demand curve, recall an increase in price will lead to an increase in total revenue. So, if I increase the price by some amount, the quantity demanded will fall. So, I will sell lesser number of tickets, but because the price elasticity of demand is less than 1, the quantity demanded will not decrease by a lot, right. It will decrease by only a tiny amount, and therefore, the increase in price multiplied by the new quantity is going to translate to a higher total revenue. So, as far as this group is concerned, because the general public group is less sensitive to a change in price, you increase the price, you raise the price, right. So, now notice the key sort of takeaway there is we had a uniform pricing scheme, but now the uniform, but I am moving away, the firm ought to move away from the uniform pricing scheme. In fact, it should charge different price to different groups. We will say a few more things about it, but let us just put that. So, the firm should charge different prices to the two groups. Can we identify what is the specific price that it should charge to each of these groups? Well, let us start with the general public group. Now, what do I know? I know that revenue is maximized. So, if I want to maximize the revenue with respect to this group, I need to be operating at the unit elastic point. So, I want the EGP to be equal to -1, right. Now, what do I know about EGP? So, I also know that this is dQ dP times the price that I am charging divided by the corresponding quantity, number of tickets that I am selling. We already know that dQ dP for this general public group is -5. So, this is -5 times, let me call this as P sub GP divided by Q. Now, I want to solve for the price. I know that the quantity demanded is related to the price as this, related by this equation, 500 minus 5 times P. So, if you told me that the price was 20 rupees per unit, the corresponding quantity demanded would have been 500 minus 5 times 20, which is 500 minus 100, 400 tickets. Now, if it is in general a P sub GP, then the quantity demanded would be 500 minus 5 times that corresponding price. And because we want to find the price, let us rewrite the Q as 500 minus 5 times PGP, right. This is my generic expression for the price elasticity of demand at some particular price P sub GP. And I know that this, if I am maximizing revenue, has to be equal to -1. So, let us equate -1 equals -5 times PGP divided by 500 minus 5 times PGP. So, I can cancel the 2 and rewrite this as 500 minus 5 times PGP equals 5 PGP, which gives me the equilibrium price or the new price, the optimal price if you like, or the price consistent with maximizing total revenue with respect to group is equal to ₹50. And therefore, the corresponding Q star is going to be 500 minus 5 times 50, which is 250. So, if I wanted to maximize revenue for this particular group, what I ought to do is I need to increase the price, increase the price from 35 to 50. In fact, I need to increase the price from 35 to 50. So, notice we already learned that I had to raise the price. So, I am going to increase the price to 50 and the corresponding quantity demanded is going to be 250. And you can actually check that the price elasticity of demand at this point, the E at this point is going to be equal to -1. I will ask you to check this, right. It will happen because we computed the 50 by equating -1 to equal EGP, right. Similarly, let us compute the exact price that I need to charge for the student group. So, for the student group, what I want to do is I want to set ES again equal to -1. So, I want to set ES equal to -1 because I want to operate at the unit elastic point. So, this is equal to, in general, ES will be equal to dQs dP times PS divided by Qs. And I can write this dQ dP from the demand curve as -4 for the student group. So, this is going to be equal to -4 times the price divided by the quantity. I already know that the demand curve is given by 200 minus 4 times P. So, if the price was 20 rupees per unit, the quantity demanded by this group rather would have been 200 minus 4 times 20. So, if I take a generic PS, the quantity demanded by the student group is going to be 200 minus 4 times PS. So, that is going to be 200 minus 4 times PS. Again, to maximize revenue, I need to equate the two things because I want the particular price P to be at a level where the price elasticity of demand is exactly equal to -1. So, I want to set -1 to equal -4 times PS divided by 200 minus 4 PS. So, if I again do the simplification, I have 200 minus 4 PS equals 4 PS, 8 PS equals to 25. So, my PS star, 8 PS equal 200. So, PS star equals to 25 and the corresponding QS star you will know is 200 minus 4 times 25, which is 100, right. So, what we have is that we have here we said we should lower the price, which is exactly what we are doing here. So, we need to bring the price to 25 and the corresponding number of tickets sold is 100, and you can again check that at this point the ES equal to -1. I will ask you to check this again, right. So, what did we learn? We learned that the firm is actually moving away from uniform pricing towards charging different prices for different groups. And if I compute the total revenue with respect to the general public group is 50. I am charging 50 rupees per ticket to each one of these individuals and I am selling 250 tickets. So, 50 times 250, so that is 12,500. As far as the student group is concerned, my total revenue is 2,500, which means that my new total revenue by charging different prices to different groups is 12,500 plus 2,500, which is rupees 15,000, which is greater than the rupees 13,475 under uniform pricing. Right. So, notice that by charging different prices to different groups, the movie theatre is able to increase its price. Well, charging different prices to different groups has a particular name. It is called price discrimination. Right. So, this is a strategy adopted by firms to charge different prices to different groups of individuals, right, and many firms do that, right. So, railways practices price discrimination. There are different types of of compartments, right. So, you have the second tier AC, the third tier AC, so on and so forth, the non-air conditioned coaches as well. So, you are charging, so everybody is going from, let us say, point A to point B, let us say Kanpur to New Delhi, we are all traveling by the same train, but some of us are in the non-air conditioned coach, some of us are in the second AC coach, so on and so forth. So, we are still traveling in that same train, but we are paying different prices for our tickets. So, that is an example of price discrimination. Tatkal pricing and non-Tatkal pricing is an example of price discrimination, right. So, you are still selling a ticket for the same point A to point B zone. We are all going from point A to point B, but some of us perhaps have purchased a Tatkal ticket, so we have paid more. Others have purchased a non-Tatkal or a regular ticket and have paid less. Airlines practices price discrimination, right. We both may be traveling from city A to city B, say let us say Bombay to New Delhi, and we both may be on the same flight, we both may be sitting on the same row. So, let us say 2 aisle seats on the same row. So, let us say we are on 14C and 14D, they are almost close to each other, but the prices that we would have paid for our tickets would be a lot different, right. So, price discrimination is a legal way adopted by firms to charge different prices to different groups of individuals. We will talk more about price discrimination later in the course, but since it has come up, I will just mention that by adopting price discrimination, the firm has been able to increase its revenue. So, by adopting price discrimination, the firm is able to increase its total revenue. Notice that if, so let me just rewrite this, by adopting price discrimination, if by price discrimination the revenue of the firm had actually fallen, the firm would not have adopted price discrimination, right. So, the fact that it is charging, and if you go to movie theatres, this is the common feature that you will see, right. We are all watching the same movie, but the price of the tickets may be different, right. People who are sitting more closer to the screen in the front of the hall, right, versus those individuals who are sitting further back in the hall, further towards the end, the price of the tickets would be different, right. Someone who is more closer to the screen perhaps has paid 100 rupees for the ticket, but someone who is sitting way back at the end, you have different types of seats also, would have paid possibly about 300 rupees or 400 rupees for the ticket, right. So, we are all notice in the same hall watching the same movie, yet the price of the ticket for different individuals depending on where they are sitting is different. So, that is an example of price discrimination. The last point I will mention here is that here we have focused on a firm which is maximizing its revenue. We are not talking about maximizing profit. So, maximizing revenue and maximizing profit are not equivalent in general, but in this example they are equivalent. What we will do next is we will look at some factors that influence the price elasticity of demand. This will come up in our next lecture.